All right, lovely, perfect. It looks like it's time for us to continue. Now, you may have seen something very strange looking and blinking here. Now, I am told it is not dangerous, but it remains to be seen. You know, always when there are those things blinking, looks like a spy movie and, you know, there's a bomb going to explode, but I'm reassured that it is not. What it is, well, there will be an explanation, and the explanation will be provided by our next speaker, for whom this is also Code Dive number 1. And the speaker is Lachezar Lechev, and his talk is called Rust as a Viable Option for the Next 50 Years of Space Exploration. Now, a software engineer with extensive experience, Lachezar has recently been pursuing his dream of working in the aerospace industry. 3 years ago, he co-founded the AeroRust community, and as a community manager, he's been pushing Rust adoption in the aerospace and robotics domains, advocating for open source and open source funding. Lachezar has also been in charge of community events and meetups, speaking at conferences and reaching out to various organizations. It is his first time at Code Dive. It is his first time in Poland. So let's have a big hand, please, for Lachezar Lechev.
Thank you for the introduction. Thank you for having me here for the first time. And yeah, you basically said the first 2 slides of my presentation, but still, my name is Lachezar Lechev, and I'm from Bulgaria. I'm, as you already heard, the community manager of the AeroRust community and also one of the 3 co-founders. I'm a software engineer, transitioned from web technologies with PHP. I was a full stack developer to Rust, to writing Rust everywhere. Since then, I've been working on blockchain and streaming backend services. And now I'm transitioning to nanosatellites and the aerospace domain and rockets. And as you can see later, you will see later, nanosatellites as well. Exactly 81 days ago, no, actually 61 days ago, I became a father to a beautiful girl, and I'm very happy with that. You can also find me on these social networks and GitHub. On X, I'm with _, but these are usually the ones that I use for work and for coding. So come reach out. I will be happy to speak about Rust and aerospace. Now, today, I'm going to give you my personal perspective of Rust journey in the past few years that I've been engaged with the Rust community. And we will begin at the beginning, of course. The first time I heard about Rust was actually from a friend of mine. He mentioned the language and he said, yeah, why don't you check it out? Back then, the Rust book wasn't very well refined yet, and also I believe it was still before or just after 1.0. And for context, the Rust programming language actually removed the green threads just before 1.0 to give you an idea of how the language evolves and changes over time. I'm also going to tell you that in 2019 and actually late 2018, when I decided to really commit to the language and learn it as it was mature enough and web technologies didn't fit my needs anymore. The things that I wanted to do and build weren't meant to be built with web technologies. So in 2018, I was fortunate enough to be in the Netherlands. And thankfully, they had a lot of meetups for Rust. And it was very good experience to meet a lot of the people that nowadays support a lot of the crates in the Rust community. And in early 2019, I was meticulously checking the newsletter This Week in Rust, checking every job opportunity, reading every blog post. And back then, there wasn't that many content for Rust. especially YouTube videos and blog posts, you could read everything that's out there. Nowadays, I cannot keep up with all the different domains that Rust is applied to, like blockchain, cloud, and we'll see a bit more about that later as well. A few months after I began full-time job with Rust, the MVP version of async await landed in stable Rust. And back then it was a game changer because until that point, Rust did have features and you could write asynchronous programs. However, you had to deal with these combinator methods and stack them into each other with closures, which was very difficult if you want to change return type somewhere, and then the whole compiler blows with a very unrecognizable error that you somehow need to debug. So the introduction of async await, for me personally, was a game changer back then. And I still remember the time where I was refactoring my code and saying, yes, finally. In Rust, you also have these so-called additions. And the compiler can introduce new or the compiler team introduces new additions every few years. And what this mechanism is for, they usually provide or add changes like adding keywords that will be a breaking change to the Rust compiler. However, if your crate uses the latest edition, it's possible, and that's how Rust compiles it. It's possible it's backward compatible for other editions. So even if you're using the latest Rust version and your dependency graph has, even from the first edition, which was 2015, I believe, you can still compile your code without any problems. Another key aspect of the tooling in Rust was the linting tools Clippian Rust format. These are pretty much from the start when I started using Rust. They were out of the box there, and they're included in the compiler as the so-called components. So the moment you actually install the compiler, you get these components out of the box and ready to be used, which makes it very easy to integrate with your continuous integration or development cycle, and provide some sort of standardization in how you format the code or some guidelines that your code needs to follow, like Clippy. My top picks for the ongoing efforts that are happening right now, and again, it's connected to the async efforts that they're doing in the past few years. The first thing is the Dual API, which affects right now the embedded ecosystem a lot, and you'll see it in a bit when I talk about the ecosystem there. But basically what that means is that you must have two different APIs for your asynchronous and blocking code. And I heard that they're talking about introducing a new syntax that will allow you to use one syntax to say, yes, this might be code in asynchronous way or blocking way, and then you have one API for doing both. Another key thing in asynchronous is the drop trait. If you're not aware of the drop trait, it's a trait that you can define what happens to your structure when it goes out of scope. And this is where the owning and borrowing system of Rust comes into play. If, for example, you have an open file and the value, the ownership of that file is in your current function, and your current function execution ends, then the drop trait gets called. And what you can do in the drop trait, for example, for a file, you can close the file and don't worry about calling it manually. The compiler will actually do it for you. Another ongoing effort is the const generics. They do have the MVP version right now, but what it allows you to do is add in the type definition a constant value of, for example, how big is your array. And this is very useful again in embedded systems where, for example, you have the heapless crate, which gives you vector and string, but of fixed size, where For example, in embedded systems, you not always have a locator, which means that you somehow need to define a fixed size string most of the times. And the moment that the buffer is full, then it will return you an error. So the API is a little bit different than what the standard library has, but this is what const generics allow you to do. There's also the statics, and I think, again, it's coming from a little bit from my experience in embedded systems lately. It's that embedded systems right now, you can define static variables on runtime and pass them around in your application. For example, have a static value, which is a mutex, and you can share these resources when you instantiate it on runtime. For constant functions, it's an ongoing effort to stabilize constant functions in STD, and it's useful because these constant functions can be used to create constants, no shock there, constants on compile time and do some computation beforehand rather than on runtime. Now, what we can actually do with the embedded ecosystem currently, and what I'm personally looking forward to. We will begin with the APIs that allow you to abstract away any kind of interface in embedded. For example, the embedded how gives you traits, and traits are what you can define as an interface or an abstract class that is a common interface for all your peripherals. For example, embedded how provides you with these traits for working with post-width modulation or digital pins, or for example, I2C bus. And here you start to see this duality in API. You have the embedded how, but also the embedded how async. Currently, there is an ongoing effort to stabilize embedded how with 1.0, finally. So until this point, and that's still one of the downsides, is that oftentimes they release new alpha version or they're releasing a release candidate, and all the community starts upgrading and your project at some point starts failing because they're upgrading these alpha versions. Another commonly used abstraction is the embedded storage. In a nutshell, it gives you abstraction over NOR flash or just storage in general, let's say an SD card, and a common interface for crates to use this interface so that they don't rely on specific implementation. Then you have the embedded I/O. And for example, they decided not to include UART implementation trait in embedded how, and instead they opted in to use embedded I/O because, again, UART is just input-output, so it made sense to not provide a separate trait just for UART. And one other trait that I really enjoy is embedded graphics, which gives you an abstraction over various targets for displaying stuff on a display or creating circles, dots, and so on. I actually created one small crate called embedded canvas, which gives you this very small structure where you can reference your picture that you're drawing based on the canvas. Let's say a canvas which is smaller than your display, and you can draw anything on it and then decide where exactly to put it on your embedded device. This is also helpful if you want to have like a transparent background of this canvas and you want to overlay it on your existing display. And it's helpful because it also allows you not to reference the display size and coordinates, but instead have like a canvas, basically. And of course, there are other crates in the APIs that are defining different things. There's also for abstracting away USB, but it's still early days, and not every crate actually uses these traits. Now on to crates, and crates are I forgot to mention it. For those that are not aware, crates are basically the libraries in Rust. That's how we call them. And there is a very good debugging probe support. Currently, most of the projects use probe.rs in one form or another. And it also provides you with this cargo flash subcommand, which gives you all these great debugging probe protocols implemented for you to use for your embedded target. There is also ESP Flash, which is a separate tool specifically aiming expressive chips. And onto the very exciting, for me at least, part, it's Embassy. Embassy, I wouldn't call it a framework exactly, but it's a collection of crates for asynchronous embedded software. And they do have their own implementations for various synchronization structures. But what's cool about Embassy is that they have their own executor, and which allows for asynchronous tasks to run on your device and get executed. Arctic is another framework, or concurrency framework as they call it, which, if you ask the developers, it's somehow like it's a real-time operating system to some extent, or in one form. But I've only once tried it, and it was a long time ago, so things have changed since then. And I can say that a lot of people are using it, but I personally don't have experience with Arctic. For logging, though, you have a few options, and probably the most used one is the DFMT crate. It has a very nice compact way of giving you the option to log stuff from your device to your computer. And proberun is the command that you use to actually communicate with such devices in this format. Proberun underneath, again, uses probe.rs, but they are different projects. Another crate that is used not only for embedded logging, but in general, even if you want to make a desktop application or you want to make some sort of a server, is the log crate, which allows you to also run on no STD or embedded device. And here I've actually added this storage question mark because I'm personally interested in this specific topic. What I mean by that is I personally haven't found a crate in the ecosystem that allows you to take these log messages from DFMT or the log crate, and while you're not connected to your host machine to see the log messages, to be able to store them somehow on SD card, for example, or some kind of flash. Continuing with the crates or libraries, you have the embedded SDMMC crate, which gives you, well, SD cards support. And they do have FAT16 and FAT32 implementation of the file systems. However, I wouldn't encourage you to use it for something like a production server or a production embedded device. Because the FAT32 and FAT16 file systems are not power resilient, which means that if you even unplug the device while you're writing on the file system and it loses power because you have not connected the battery, then it's possible for the file system to get corrupted, most often than not, and then you have to format the whole SD card, for example, or rescue the data in some other way. Then I've listed these two file systems. Probably there are more, but I haven't found use of them, or I haven't looked deep enough in the crates registry. The first one is actually a Rust binding to a C library, and it's called LithoFS v2, which is LithoFS is this C library that gives you a file system which is power loss resilient, and it also has wear leveling, so that you don't wear out your flash or SD card too fast while writing on the same section of it all the time. Then one of our community members actually is developing this VLFS file system. The interesting part is that they're using it for their rocketry club. So they're using it to build their own rocket. And it's built on Embassy with the Embassy synchronization structures. And it's currently only targeting NOR flash, but it's something that I really wanted to share with you and yeah, for you to take a look if you're interested. Something to mention, there is a link to my slides at the end. So if you're interested in checking all these links that I've added to the presentation, you can check out the link. For embedded, of course, you have many sensors, many drivers for displays, for pressure sensors, for whatnot. And I'm not going to list them all, but I wanted to mention them because, again, it's still a developing ecosystem. There are plenty of sensors, there are plenty of displays that are already supported, but there is a challenge when you want to build a project. Because oftentimes, they use a very old version of embedded HAL, for example, which is the stable one, but it's like 4 years ago, the last version that was released. And oftentimes, they are not very well tested. So you will find bugs when you try to use these crates in your project. And something that I'm very interested and excited, I actually heard about this project in 2 weeks ago. And this is the North Star container runtime, which is targeting embedded devices. What's cool about that, maybe again you've heard about edge computing in space. And this is where this container runtime can play a very good role. Because if you can run containers in an OSTD environment, this is a very good application for space. And also it allows you to run multiple clients' code on your satellite, for example. Rust in other domains and applications, just to give you an idea how or what crates you can use, what things you can do. And we begin with the asynchronous backbone of Rust. The first crate, Tokyo, it gives you the so-called executor for asynchronously running your code. And it manages all the abstractions for you to, let's say, use your CPU most efficiently, all the cores and so on. And they do provide you with synchronization primitives like mutexes, channels. They have signals and many other tools that you can use at your disposal. It's what you start with when you start writing a Rust program in an asynchronous environment. Then you have Hyper and Tower. Hyper is specifically targeted at clients and servers, for HTTP clients and servers, but it's very low level. Usually, a lot of people have built tooling or frameworks on top of it. There's also Tower, which is, again, for building clients and servers, but for networking in general. And then you have Request, which is a very nice and complete crate for making HTTP requests. So if you have like a REST API that you want to call, Request is probably the thing that you want to use. And for example, they also have like a blocking client, but also an asynchronous one. There are many web frameworks, but at least my favorite one is Axum. I just like how they do certain things. I extract paths variables or query parameters, and I highly recommend it if you're starting with Rust. And it's again asynchronous. Then for CLI, you have Clap. Again, there are a few other options, very popular ones, but Clap is the one I personally use. And they even allow you to define your CLI interface in 3 different ways. The one that I like to do is the derive macro, because it gives you this structure with all the macros for specifying, okay, what's the short version of your argument for this CLI application? What's the value that it takes? Is it mandatory or not? And so on. Another mention that I want to do is the Queen library or the Queen crate. which is a quick protocol implementation in Rust. And Occam is a very nice, again, set of tools, I believe, is the best way to explain it, for writing distributed systems. And the very cool part about it is that it supports no STD, or this is basically without the standard library of Rust, where you need allocations and file systems and stuff like that. So what Occam allows you to do, actually, is, for example, you have one device that's connected, the first device connected to the second one through Bluetooth, and then the second one connected to the third one through Ethernet, for example. And Occam allows you to have this route from the device 1 to device 3 handled automatically for you with the correct route, of course, and send messages between these devices. And it handles the different mediums that it has to send this message through. Cloud is also very popular with Rust. You can use it to write serverless. You can use it to write Lambda functions. You can even interface with AWS if you want in your code, or Kubernetes. This is probably one of the bigger domains that companies actually latched pretty early on to use Rust for. And here, for example, I've added, again, a few of the subcommands that you might be interested in. Cargo is a tool that comes with the compiler, and it's how you actually run your code or run, for example, the lintings and so on. Cargo Generate is a very nifty tool for taking a template repository and generating your own new project. It allows you to have like variables that the user defines when they want to use your template, and for example, to specify what kind of a board or a chip you're using, and depending on that, to include the correct dependency in your project. Then you have Cargo Release, which is primarily used for publishing your crate on a registry. Then you have Cargo ESP as a subcommand. We already mentioned that ESP flash is used for flashing expressive chips. There is Cargo SEM version checks, which will double check your API for breaking changes and tell you, okay, now you need to bump up the minor version or the major version, depending on the API changes that you did. Cargo Dist is a more generic tool for releasing just software, not only for publishing your library or crate in the registry. And Cargo About takes your dependencies, finds all the licenses, and provides them to you, for you to evaluate if all is right or if they align with your project and goals. Now, let's talk about Rust adoption and safety, and a bit more. And I think it's a good continuation from the previous talk, which again, they mentioned Rust. But let's talk about who is actually using Rust and to what extent. What's the current state? At least currently, there is one French startup. You probably can find it with a quick web search, which is doing space-related stuff with Rust, or let's call them satellites. And there's also two big private companies in the US that are using Rust, but because they're private and somehow they want to keep this information from the public until the time comes and they become public, I guess, to use it as an edge, they actually hide it. However, what I've seen, and that was a few years ago, I haven't checked if they are already listed new positions, but both SpaceX and Rocket Lab at some point had a Rust flight software opportunity listed on their website. So this gives you an idea that they're either still waiting or they're already using Rust for their applications. Ferrocene is an effort to document and certify a Rust compiler for safety critical applications. right now they're focusing on automotive, but they want to eventually go to aerospace as well. Continuing with automotive, OxyOS is an operating system for cars, and not only in entertainment systems, but you can use it for the whole ECU. And one member of the community actually created this blog post that tracks the adoption of Rust in various domains. And they also included the space domain. So you can check it out if you're interested. More people that are using, or more organizations that are mentioning or using Rust for safety critical systems. First, you have a very nice talk on Rust conference last year that was talking about electric frame traits. I highly recommend this talk because it gave me a pretty nice picture how they're actually using macros to build their state machines, and it was very interesting to me to see. And you also can see these organizations and manufacturers that promote Rust for your safety critical applications. Now, I'm a community person, so I cannot skip through the community part. These are, again, just a few of my top picks of communities. But for example, you also have a very large Bevy, where Bevy is a game engine, Bevy community in Discord. So if you're into any kind of game development, or just you want to create something with a game engine, I highly recommend checking Bevy. Then you have the machine learning community, which is on Zulip, I believe. There's the computer vision one on Discord. And there are a few matrices for Rust embedded, Embassy, and Espressive for Rust. And of course, last but not least, we have AeroRust. So what is AeroRust? Well, AeroRust is the Rust community for aerospace. What do we do? Well, first of all, we are a place for meeting. People meeting with, a drive for space exploration, or just the application of the Rust programming language in space, aerospace, and for hobbyists and professionals. We already have a lot of community members, including people working in the aerospace domain and the space sector. So this gives you an idea that there's quite a big interest, but still there isn't big adoption, let's say it this way. We try to create learning materials for people to use if they want to start with aerospace. And we're building the ecosystem of aerospace in Rust. This means creating crates, projects that are targeting aerospace. And last but not least, we're advocating for Rust adoption, of course. I'm not going to skip that, right? We're organizing events. We have a YouTube channel that you can check the recordings at. The first meetup that we had recorded was the QAV1 CubeSat, which was a university project. We did a takeover of Rust London, talking about aerospace. And this year, for a first edition, we managed to create a space-related conference in Plovdiv, Bulgaria, where on the second day we actually did a workshop, and this is part of the workshop, but I'm going to talk about it in a bit. And we also have bi-weekly, by now we already have a bi-weekly meetup, which is like a casual meetup on Discord, discussing stuff like aerospace, space, and Rust, of course, and everything in between. As for projects, we have the Are We in Space Yet crates catalog, which is a catalog of aerospace-related crates. We have a drone project for the Mavlink protocol implementation of a higher level API that allows you to speak easier with the drone if you want to do simple commands. Probably the most used and most contributed crate that we have is the NMEA crate, which is what, for example, a GNSS receiver for GPS or Galileo will actually give you out as an output to say where you are or how many satellites are in view. And then, as I mentioned, we had the embedded workshop, and it's open source. And of course, come join us. We're learning all by each other. It's a learning experience. For me personally, I've never worked in aerospace, so I'm kind of getting from the bottom up approach to learn as I go. We have the YouTube channel. You can check all the projects on GitHub, or just follow us on Twitter or X. Now, on to our open source workshop demo. So first, to showcase, can we have the camera? So it's a work in progress, but we've added a few extra things since the first initial workshop. I can show you here that we have a bottle with a pressure sensor, just to showcase that students might use it for experiments, or an actual application in space would be some kind of a pressurized container. Here, hanging on the side, we have a GNSS receiver, which we will see in a bit when I run the code, but since we're indoor and there are no windows, we will not get any lock with the GNSS receiver. In this case, we also have like solar panels to charge the battery, and two little boards that play the role. One is playing the role of the power system that tracks the battery percentage and communicates this with the other board, which plays the onboard computer part. Now, it's blinking, but I'll flash it again just for you to see it. Let's see. So now we're connected to the power system, which tracks the battery percentage. And as you can see, the ESP flash is integrated when you just call cargo run, which is very nice, just to have one command and your chip is already flashed. As you can see, we can track the battery here, which is very simple, but again, very useful if you want to track how well your battery is charged with the solar panels, and of course communicate this with the onboard computer that actually decides what to do, for example, when the battery goes lower than a certain percentage. Now this is the less interesting one, and now I'm just going to stop it. It will continue to work because it's connected to the battery right now, but if we switch to the onboard computer, let's see. Okay. As you can see, it's easy as cargo run. Okay, it's cut off a little bit, but it's fine. As you can see, we do get information and we're parsing these NMEA sentences. However, we don't have any satellites in view, again, because we're indoor. And we do get a few more messages, but this is just a few that I'm filtering out just to show you that we can track Galileo, or for example, GLONASS is also very popular, or is supported. Baidu is the Chinese one. And for example, you can see here that we can we've set up the pressure sensor and with some values, and we're logging this to the console, the development console, directly from the device. But also setting up some things for the GNSS receiver, like enable Galileo, not only GPS and Baidu, but enable Galileo, which is the European implementation of the GNSS system. Now, let's see. Okay, if I run it and I switch to my other tool, which is not written in Rust, but it's a very nice way to showcase the pressure sensor. Now we're just going to select the USB and connect. And hopefully we'll get the dashboard. Nope. Let's try this again. Okay. I have this serial to USB cable that might be. Sorry? Yeah, I just reconnected the whole cable. Let's see. Nope. Well, live demos for you. Let's try again. Clean it up. Run it. Yeah, I haven't connected it actually. That's why it's not showing data. Let's quickly fix that. Do I have time? How much time do I have? 6 minutes? Okay, that would be enough, I would say. Yeah, no wonder. Come on. Let's go. Okay, done. Let's try this again. Come on, connect. I know you can. Okay. Okay. Let's try again. We connect to the USB. Thank you. And this is just an experiment that students can do, but to showcase an actual use case of a pressure sensor, if we squeeze it, you can see like the pressure rises a lot, the meters go down because it's higher pressure, and also usually the temperature rises up a bit, but just a very small amount. Okay, that was with the demo. On to the last slides. This is a community effort, and these kits will be provided as a training but also educational platform for embedded. We want to go over a simple setup that's actually usable to some extent. So you will be introduced to UART, for example, or I2C, like the pressure sensor that we have here uses I2C. The GNSS uses UART. And these are intended for students to purchase, but also support the community effort, because we want to make our community sustainable in order to be able to create more content, to create this ecosystem, and yeah, in general, to improve the aerospace ecosystem. You can check out the project here. It's still work in progress, as you can see, but hopefully next year we'll have the first orders and also deliveries. In conclusion, well, even though I admire Rust so much, I don't think that it will be the language used for technologies like we see in Star Trek and Star Wars. However, it's currently on the right track to be the language for the next 50 years. As again, as my talk title. And it's up to us to see how we can support this growth, but also make it sustainable so that we have more open source projects and tooling available. One caveat, well, predicting the future is hard. And you can check out Neil deGrasse Tyson talk on this topic. It's very entertaining. And I can be completely wrong, but who knows? That's what the future will show. And thank you. Woo!
Thank you so much, and congratulations on your finally working demo. Any quick questions, anyone? Thoughts? Thank you. One over there, please.
Hello, and thank you for the presentation. My question is that how do you compare Rust to alternative other choices? Why Rust? My big question, and I would like to hear the answer. Thank you.
For me personally, when I started with Rust, there were two things that were equally divided, like my choice. One, the language itself. It's memory safe. It has nice features that are built on like 50 years of research and development for language features and so on. However, the other half was the community itself. And I really like that part since the beginning, because the community itself, although there are bad times, of course, in every community, but primarily the community is very open and also very welcoming to new people. And that's also one of the things that I'm really hoping to be capturing in the AeroRust community. Because oftentimes newcomers come, like, I don't use Rust, or like, I'm not in aerospace, I don't know what to do, but I'm very keen to trying out Rust at some point and somehow working in aerospace. And we want to foster these people to actually become the experienced people that will guide Rust in the right direction in the future. In terms of features and stuff, well, there are many more and smarter people that have talked about that. There is also Microsoft that have spoken about memory safety issues. And I highly recommend just checking out some of these blog posts, because they will give you a good understanding and in why Rust is such a nice fit for such applications and safety critical stuff.
Thank you.
Quickly, one more, anyone? Thank you so much, Lachezar, and hopefully we're going to see more of your developments and demos, yeah, maybe next year, who knows. Other than that, thank you so much for coming. Thank you for talking to us. Everybody, Lachezar Lechev.